Good morning. I think we have most everybody joining us. So let's go ahead and get started. My name is Stephanie Helcrow. I'm a visiting scholar here at NDIA's Emerging Technologies Institute, or ETI. And I'd like to welcome you to the third of a four-part webinar series on digital transformation for acquisition. ETI is doing this series to discuss the tools, tips, techniques, processes necessary to implement digital acquisition across the ecosystem, from prototyping to engineering to contracting to supply chain to sustainment. Today's conversation is going to feature four industry partners and talk about the art of the possible. But it's just not the hypothetical art of the possible, but actually what is being done currently. This is the third of a four-part webinar series. The first webinar was with some industry leaders and senior government officials setting the scene to discuss what is digital transformation for acquisition, why do we need to do it. The second webinar featured former and current program managers to discuss what is actually being done in programs in establishing a digital acquisition ecosystem. And so here we are today with our third in this series discussing the art of the possible. I'm really excited to hear from these four industry partners, and I'm going to turn the mic over now to Anna Kim, who is a research associate at NDIA's ETI, and she's going to moderate today's session. So Anna, over to you.
Thanks, Stephanie, and really looking forward to our set of speakers today. As Stephanie mentioned, we've heard in this series so far from thought leaders and program managers, and today we'll get another angle on the practicality of implementing digital transformation for acquisition with a series of lightning talks from industry representatives who have tools and solutions in use now to help the Pentagon implement digital methods. As you can see from our run of show here, we'll be looking at these approaches across different stages and elements of the acquisition lifecycle, from program management through to sustainment. Their actual presentations have much more interesting titles, but this is just to give you all an idea of how we'll run through today. Our ultimate goal is to showcase the art of the possible, as Stephanie said, through these case studies of what's available now to support digital acquisition. So with that, our first lightning talk will be presented by Price DeSanctis. He's a model-based systems engineer and digital engineering practitioner at MTSI. MTSI, or Modern Technology Solutions Incorporated, is a 100% employee-owned engineering services and technology solutions company, delivering first-choice capabilities to solve problems of global importance. They have over 2,650 employee owners with locations in 15 states, and MTSI supports the U.S. military, Department of Homeland Security, the intelligence community, as well as industry. So with that, Price, over to you.
All right, let me share my screen here, make sure I get the right one. Excellent. Anna, thank you for that introduction. I am Price. I'm probably the working man of the group, and as my bio mentioned, I focus on model-based solutions in the system, mission, and in enterprise spaces. And then I work on integration and visualization of those artifacts with other points of the life cycle. So to really make my job easier, I've begun to use that aforementioned enterprise model-based spacecraft to create proper integrated digital environments. I hope to show you today that crafting IDEs properly requires a digital process in and of itself, but it will quickly lead to a lot of digital transformation that can produce some tangible results, as we'll walk through 3 use cases in the end. So this is a quick overview here. We're going to hit some rather redundant slides rather quickly. I know these have probably been hit on quite a bit in the previous sessions ad nauseum, but I want to set the stage a bit for how this process and our latter success story slides kind of blend together when we get to those. So let's hop right into it here. I stole this from our marketing team at MTSI at the request of some of the betters in my company. We've probably all seen something like this before. As you'll see, I use different layouts and diagrams to depict the way towards digital transformation. A lot of people are going to see this and believe that digital transformation is a heavy lift, right? I mean, this slide prescribes 3D representations of their system directly linked to MBSE with programmatic data, expensive AI/ML all in the middle, et cetera. So once again, I hope today to show you that digital transformation isn't about buying new tools. It's actually about connecting goals, processes, data, and infrastructure into a traceable, integrated digital environment representation first, and then to go build that environment afterwards. Essentially, on the right, we want number 4 there to enable 1 through 3. But this is an iterative process, in my opinion, and should be treated as such. So today, I am going to focus on 1, 3, and 4, although I do certainly adopt from Agile principles, right? I think this whole transformation process is about people and processes and not the tools themselves. I like this one a little bit more. Although I use a little bit different flavors here on these phases, I generally follow this pretty much to a T. I do try to make phase 3 obsolete as much as I can. So my goal when helping an organization with transformation is to use what they've already got, right? We want to connect the already existing tools together and not buy some one size fits all tool typically. Obviously, that's not always the best choice. And more times than not, we're going to be able to actually just undertake this process from phase 0 through 4 without really buying anything new for the most part. So as a ground floor type of guy, I firmly believe the critical enabler for digital transformation in an enterprise is an IDE and its interactions with the folks doing the work. So you want digital threads and traceability, right? We better ensure the tools that we're using comfortably by people in different domains are connected together. If you want agile enabled CI/CD pipelines, the stops of that pipeline, they better be well defined, right? And they better be integrated. You want to build those beautiful MOSA compliant architectures that prevent vendor lock. You better practice really good data governance, and you better lay out what you expect from who and when you expect it. You want multi-level security. You better know what data is in your environment and what of that data can go where, what can't, and then you can develop safeguards to keep it that way. It's probably nothing you haven't been told before, but today I want to tell you how I think you should go about building and maintaining this digital enabler, and that is not by connecting things just to connect, not by buying tools just because they are shiny. I firmly believe the most effective way to make sure your IDE enables that wonderful triangle we saw earlier and the thousands of variations of it is by employing enterprise architectures. So if you want traceability of tools that deliver an efficient end product, take stock of those tools in step 0, just like we saw. We can do that with resource architecture views, as you'll soon see. You want to ensure your IDE is supporting the people undertaking the steps at each part of your process. Make sure you can tie that resource structure directly to that process. While we won't specifically go over those traces today, this is a very easy thing to do when that underlying infrastructure and your desired processes in the same environment, such as an enterprise architecture. So EAs, as they're commonly referred to, are relatively quick builds, especially if we keep them targeted in scope. So let's see how we can build these architectures to enable the building of those IDEs. Just like the phase 0 of digital transformation that we saw, we want to kind of define the intent of our enterprise in the architecture as well. So to me, this is what capabilities do we want to deliver, right? What's standing in our way right now, et cetera. We want to anchor everything we do after this in this intent, right? We don't just want to go digital for the sake of going digital. For those familiar with the modeling standard called Unified Architecture Framework, or UAF, this would mean laying out capabilities, challenges, driver elements, et cetera. Most enterprise architectures are developed in UAF, but some stay in the less extended SysML, which is fine. Regardless, we need to capture those and then trace to them along the way. Now we want to continue in that phase 0 of the transformation, and we'll map out our current as-is enterprise, right? So this means both processes and that underlying infrastructure, right? What are we working with? What are we trying to do, et cetera. For the sake of time, we're only going to show the infrastructure as examples today, like I said before. And listen, this is often pretty ugly. That's okay. It's important to know the issues we want to solve before we go on that transformative journey. The next 2 are really kind of intertwined as we move towards steps 1 and 3 that we saw on that previous chart. We want to design a 2B architecture, right? And that's both the desired process and infrastructure again. So that's going to lead to the formulation of that golden IDE we want to eventually go and develop. At the same time, we want to make sure that we're connecting both of those future items together, right? So if a tool isn't mapped directly to a process, then it doesn't need to be in our IDE. And additionally, if a process doesn't produce one of those desired capabilities we talked about before, well, then why are we spending valuable time and human resources conducting it? I could probably write a dissertation about this traceability here, but actually at the end, if we have time, I'll give you a great free resource from CATIA, the makers of the most popular modeling tool, that shows you how they do this process using UAF. It was very helpful for me when I kind of started this process. Now, this might seem like a lot of work here, right? The whole as is and a whole to be enterprise with processes and resources, et cetera, and traceability all the way through. So believe it or not, good modelers are actually faster than you think at laying these out, but this is still a lot. I mean, even I'll admit it. So thus, I think you should just hit pain point targets one at a time. This whole top-down process can be done in one domain or one pain area at a time. You can define one capability, layout, and map to its current and desired states, and then go implement that area. As you're going to see with our examples in just a second, we actually take kind of small issues and make hasty results, both in the enterprise architectures themselves, and then going and creating real tangible results that help deliver those capabilities rather quickly. So do this a few times, and the next thing you know, you've got a full enterprise architecture whose as-is infrastructure now represents a pretty robust real-world IDE. So I'm going to show you 3 cases where I've personally been involved in this targeted process, both as an enterprise architect, and then even using the final digital results to produce cohesively integrated visualizations. That's my specialty. So we're going to walk you through some of those right now. All right, our first real world scenario, I call the MOSA compliant platform architecture stack. And you can see a current diagram of, right, this is kind of that as is infrastructure there, right, and our targeted problem area. So those are UAF elements like we mentioned before here. So I've simplified this data a bit, but you can clearly see some issues, right? We've got a poor PM there who's going to try to use this data to make decisions, right? And he's got to hop into multiple different places to see the data. He or she probably hates Cameo and can't figure out what these supposed digital artifacts mean or what they're supposed to do with them. And additionally, he or she is having to try to find the latest spreadsheet with the platform's cyber risk and try to figure out what all is going on there. Thus, the first capability they requested is they wanted tool agnostic analytical analysis. Secondly, they want to be able to actually integrate cyber data and that process that they undertake to the system engineering data and processes. There was currently no link between the two. And lastly, they want to become a little bit more modular, right? They want to go after that MOSA compliant divisions of architecture and implementation. So we've got our capabilities, right? And now we can see what our to be ended up being, right? We actually laid this out once again to get everybody on the same page. So we clearly fixed those analytical problems, and we didn't go buy a tool here. We used a previously created tool catalog that the organization had and realized that they already had Microsoft Power BI, which is a great integration and visualization tool. It happens to be my favorite one, as you'll probably tell in just a little bit. So we can bring the data out of the models, which we'll do from just pulling from that bottom model because it can see the rest of them in Cameo. And then we'll pull the cyber data as well. Secondly, we worked with those cyber engineers to modernize their process. We actually built them a profile that allows them to undertake their chosen cyber-based analysis called STPA-SEC directly in Cameo. This did 3 important things. One, it's easier for the cyber folks to make rigid connections from the actual cyber data, that STPA-SEC, over to our system architecture. So that's kind of capability number 2 right there. 2, the PM didn't have to buy a different tool, right? We just had to add a few more licenses to Cameo. So he or she was very happy with that. And 3, with both data sets in Cameo, we could make traces from adversary attack points, et cetera, over to that architecture like I referenced. Lastly, we split that model of models into 3 different ones, right? So one there is going to serve as an authoritative architecture. That's like a GRA that the government would provide the OEM. The next was a solution space where OEMs could develop a system and then trace upwards. And then lastly, we reused a library that allows for the conversion of real world hardware, interfaces, and all the capabilities of that hardware into SysML. So you could actually implement that system, which is implementing that architecture. And that's kind of what we refer to as a MOSA compliant stack. So we implemented this pretty quickly. We built some pretty slick views from it as well with all this connected data, which we're going to hop into right now. So this is a live dashboard. This is Power BI embedded into PowerPoint. So this represents the one that we built for the program. So this dashboard right here is going to extract from that MOSA compliant stack. If I go to the right place, is going to extract from that MOSA compliant stack we talked about. So you can see the kind of different SysML representations of real world components that implement our architecture here. So we can flip between different kind of configurations, and you'll see some data change, right? You'll see our cyber data change a little bit, as well as some kind of rudimentary production costs that are going to change as well. And even further so, we can actually dive down even more into the data here. If I want to know about this exact implementation component, I can click on it and pull from that kind of bottom library, right? And I can see the different interfaces. I can see some details about this. We eventually connected SBOM data. That was kind of phase 2 of this targeted implementation, et cetera. Lastly, I can see kind of cyber-specific scenarios here, right? That are pertinent just to this component. So how were we able to do this? If you remember, our cyber team now works in Cameo as well. So they can use this STPA sec page that we have built for them. They can go through their process. Then they score those, which is where we're going to get that color coding, right, of those kind of risk adversary based scenarios. And then remember, we connected that to our system architecture, which is, of course, connected all the way down to that component library. So here at the end, we can take all this data, hand it off to like a penetration tester, right? So after all this is implemented, we can kind of recall the data that our cyber risk analysis team was worried about at the very beginning. So on to scenario 2. You guys know the drill now. We've got a user, and this time they're more of a worker bee, not necessarily a PM. They've got to try to look at mission scenarios in a modeling tool, try to build AFSIM data to run it, and then they have to look at learned data such as financial and other items and take all that into account, right? Like I said, sometimes these things are ugly once we lay them out. So a couple of things we want to do here. We want seamless movement of data between all these tools together. We want to bring all that data out to a single point of analysis, right? Spoiler, we're going to use Power BI again. And then lastly, the customer requested some AI/ML in the middle here. So after laying out these requirements, we decided that there needed to be a tool in the middle, right? I told you not every time can we just reuse tools, right? So we're actually going to build a tool here at the customer's request. So here's the good news, because we laid all this out in an enterprise architecture, that architecture can actually help us build these. So we can use that structure that we created there, and we can depict data flows that actually need to occur to fulfill that tool's capabilities. You can see up top here, we expect mission characterization to be built in our MBSE tools, and then our tool in the middle there is going to extract that data and get it into a readable AFSIM format and push it over to AFSIM. So we can lay all this type of stuff out quickly in our enterprise architecture. From there, we can actually, I pulled this into Power BI here once again, but we actually built a little JIRA parser as well. So we can lay the things that need to occur for this tool out in an enterprise architecture, bring that out to a workflow management tool, and then allow our modelers, our developers to know exactly what they need to do based on the models that we laid out. So this is kind of the end game of that. And I'm running out of time here, so I'm going to move very quickly. You can see this is kind of a mission MBSE view. And once we get down to this mission thread point here, we're going to be able to pull a bunch of different data together based on these kind of mission engineering threads. You can see our different kind of mission engineering threads that could implement the way we want to destroy Rogue Nations A's C2's capabilities. And this is where we can build these things out in MBSE and see the details here. And then we can run them in AFSIM and bring that data to the same point, as well as we've got learned financial data, right? How much it costs to fly something, how long it's up in the air, et cetera. We can bring all that right here to our PM. So lastly, and this one is very quick, this was where I actually started my endeavor. So the before slide does not exist here because none of these things were connected. You can see we've got a control ledger that's in Excel. We had a schedule repository for our program at MDA that was in Microsoft Project. We had IBM's EWM, which is a lot like Jira, right? It's workflow metrics. And our PM's ask was pretty easy. It was show me what the heck each of my sub organizations is doing and how much it's costing me per ground test event. So we actually had an enterprise architecture, as you see, that's right here. It's going to provide what we call semantic layering. I'm going to breeze through this here. We use a tagging process to tag items in this enterprise architecture with their relevant IDs, right? Scheduling ID, the kind of workflow item ID, as well as the financial ID. And we're able to bring all that out. And there you'll see that same product, that ICD version 3.0. And we can pull all that data here. You can see kind of the Jira type views here. You can see the different the financials, right? Our line items, how much we spent, how much we've allocated to this product, et cetera. This is kind of nice to see that we're kind of on track here, right? 47% done, 47% spent. That's always good to see. We can pull scheduling data both for this product itself as well as the ground test that it's going to be involved in. So we'll pull all that data right here for our PM after laying that out in an enterprise architecture. And that's really going to set the stage for the fourth bullet point, if you'll recall that process slide there at the very end. And that is AI/ML integration. So by semantically connecting all these things and feeding that data to these AI/MLs kind of in a repetitive manner, which is very important, not to give them a bunch of different crazy inputs, we're able to kind of run calculations here. We'll be able to tell our PM per ground test, hey, for each team, this is how much their Jira metrics say they're complete. This is how much they've spent. They're pretty much clearly over budget. So there's a little bit of AI/ML working here through Microsoft's Fabric that's bringing these metrics to PMs real time. All right, so summary and hopeful lessons here. I hope I taught you guys a couple of things. When IDEs exist, digital transformation is going to become a lot easier for us. And to build those, lay those out on paper or in an enterprise model, right? Digital paper, so to speak, and then let our practitioners tie it to the process that they're doing. Make sure all that stuff is connected. And then lastly, do this in an iterative fashion. You don't have to do this all at once, but if you do this just a couple of times over and over and over again, next thing you know, you've got a full-scale IDE that's working for your organization and you're creating cool Power BI views like the one that you just saw. That's all I've got today for the sake of time, so I will pause there for questions.
Great, thank you, Price. Great presentation. I really liked seeing through your demos how you work with and pull data out of existing tools that a program has. Since we have a minute, there is an audience question for you,
Great.
which is, do you see each program or individual system having its own IDE, or is it done at a higher level, maybe as a system of systems?
That's a really good question. So typically when we get pulled in, it is at the kind of system level, unfortunately. But the good thing is digital transformation is contagious. So once we kind of do that in a targeted environment, so for instance, when we go all the way back up here to this view, right? This was kind of a mission engineering team that's trying to do this, right? Now they're supposed to flow that data down to the rest of the organization. So typically we do start at the program level or maybe the domain level, so to speak. And that's honestly how I started the kind of targeted approach. Now, the good news is once we kind of create some digital goodness here, it's a little bit contagious. So next thing you know, well, the systems team wants this mission data flowed down to them. So next thing you know, we're going back to this same enterprise architecture we built and say, okay, all this cool mission data that we're able to create in this analysis, how are we going to connect that down to the systems domain? And we'll do it in that same enterprise architecture. So I wish it was full, we could do it with a full program at once. But typically we do domain by domain and try to connect those at each point. That's a good question.
Awesome, thank you. We're going to move along, but I want to note for the audience that we are going to collect all questions for presenters and convey them to the speakers afterwards so that they can get back to you on any questions you have. So please do keep sending in questions through either the chat or the Q&A function. All right, so next we're going to hear a presentation from ML Mackey, CEO of Beacon Interactive Systems. Beacon is a digital innovator and a successful non-traditional defense contractor delivering digital capabilities that modernize and transform operations, maintenance, and sustainment for the U.S. Department of Defense, allies, and partners. Leveraging commercial sector expertise in support of critical national security needs, Beacon has transitioned multiple products into DoD programs of record. Their products digitize flight line operations for the Air Force, transform program management activities at OSD, and are in full fleet deployment across the Navy. And with that, ML, over to you.
Thank you, and I appreciate that. I'll pull my slides up. All right, good afternoon. As Anna said, my name is ML Mackey. I'm the CEO of Beacon Interactive Systems. Beacon is a high-tech innovator headquartered in Boston, Massachusetts, with offices in Brooklyn, New York, and Norfolk, Virginia. Our products streamline operations at the edge, supporting successful mission execution while increasing operational capacity across the Department of War. Beacon's story is one of commercial products transition to dual-use impact. Our engagement with the Department of War began with initial cyber investment to translate the operational impact of our commercial technology to national security needs. Follow-on engagement to those initial cyber investments further refined our product offerings and the delivery of those capabilities for the warfighter. On this slide, you'll see some of the organizations we've worked with and some of the capabilities we've delivered across the Department of War. The operational impact of our digital products is improved delivery, operations, and sustainment of equipment at the edge. We've leveraged the technology inherent in the Beacon platform to deliver products across the Navy, the Air Force, Army, and OSD. Before going too much further in describing our products, I'd like to take a moment here to articulate where those products fit in the digital acquisition lifecycle, the topic of this webinar. Our initial stakeholders are the soldiers, the sailors and airmen at the point of performance at the edge. Our digital transformation focus, our North Star in product development is process. And how does that flex with real-time evolving operational impacts? Our products are compelling to our end users because they directly support the work they do. For us, focused on operations at the edge, digitally transforming operations at the edge, the penultimate description of digital transformation is a disciplined focus on process. How does work really happen at the edge? How do we build a system that therefore is truly a supportive capability versus an additional reporting burden? Because of this focus, our customer adoption and pull is high. Our systems fit their processes seamlessly. So in terms of relevance to the acquisition lifecycle, this high user adoption and use generates a tremendous amount of information, operational data about what worked, what didn't, and where are the operational gaps. This information is critical to informed acquisition decision-making. With that, onto our products. Our Navy programs of record are deployed across 19 ship classes, 226 ships, and multiple shore-based locations worldwide. These are the ships that are actively using our products. And these are the products we've delivered to the Navy. So starting in the top left, eTagout is the electronic tagout system for the Navy. It is the system that digitizes the work instructions and processes to isolate equipment and then authorize maintenance work to occur. Next is SEAS, the Shipboard Energy Assessment System. It's the Navy's operational energy command and control system on the bridge. It tells you how much fuel you're using, how much energy you have, and what you could do to increase your days on station. Bottom left there, still shipboard, is eLogbook, the electronic logbooks. This is for the watchstander. It replaces the paper logging process mandated by law that must happen and improves it with a digitally transforms the paper process to do the watchstander logging. Moving to the right of this slide, in the top there you see missile. This is digital transformation for land-based test facilities. Essentially what we did here is take all of what we had done shipboard, integrated it, and layered in the event management that's necessary for test cycles, as well as additional capabilities for the intense configuration management necessary to manage multiple test events. And in the bottom right here, we have Flex, Forward Logistics Expeditionary. This is that same type of operational support at the edge for unmanned systems. How do we take care of the operator? How do we make sure they have confidence in operating the assets that they intend to use? So with that, I'll walk through each of these products more from like an operational impact perspective. And I think this is what, Stephanie, when we talked in the prep for this, that you were looking for, is how does this aspect of digital transformation inform and affect the overall acquisition lifecycle? So when we look at eTagout, the operational impact, at the base of it, what I want to communicate to you is it's all about safety and efficiency, but it's also real-time visibility into the readiness state of the equipment. Not just is it on or off, but is it available? As in, is it isolated from operations and in the midst of a maintenance action? So this is that live connection to operations, this full operational data picture that the focus on an IDE in the last presentation is critical for that piece of work, and ours is about the process, but it feeds directly into those kinds of IDEs. It's an interesting continuum in the presenters that you have here today. All right, the next product that I'll tell you about is SEAS, the Shipboard Energy Assessment System. The immediate and driving operational impact for this digital transformation effort was about increasing days on station, increasing the time between refueling events, which is more and more relevant as we move to increased participation in INDOPACOM. It turns out it's also about situational awareness. SEAS provides shipboard, bridge-based decision support in the moment while deployed, reactive to evolving operating conditions. E-logbook, the operational impact here initially, the impact driven. It's interesting how there's one impact for digital transformation, and once you get there and you start automating the processes and you start capturing data, that so much more can be derived from that investment. So I'll talk first to the operational impact of increased accuracy, visibility, and efficiency, and the required logging efforts that have to be done legally for all events on a ship, right? E-logbook is now the legal record of all events and operational impacts happening on board ship. It's translating that paper process to a digital experience. It's a tremendous source of operational data, both in the moment on the ship and for shore-based assessments. Flex, the operational impact here is maintenance and operations efficiencies. This directly supports the operator at the edge. With unmanned systems deployments, there aren't typically a team of trained maintainers deployed alongside with the operators. Flex directly supports the operator to confidently engage and use assets effectively at the edge. Additionally, Flex deployed on an edge device, which we've done with PEO USC and working to deliver this capability for USV and UUV platforms. Delivering on an edge device, this mitigates the need to send assets back for repair. It lets us take care of deployed assets in the field. It saves costs, it increases uptime, and it ultimately directly provides visibility into the operational availability, A sub O, of your unmanned fleet. Missile. The operational impact of Missile is getting assets through test cycles more efficiently. For Missile, we essentially took the shipboard capabilities we had deployed, fully integrated them with each other, and implemented those processes for shore-based facilities. As I described earlier, it's with the added support for test events and the heavy configuration needs of those events. For the Air Force, we delivered airs. It's kind of clever. For the Navy, we delivered seas. For the Air Force, we delivered airs. The operational impact of airs is that it's all about getting the plane back up in the air faster. In delivering airs to the Air Force, we worked with over 1,000 maintainers across 4 MAJCOMs. This is that focus on operational process and the discipline to make sure that our digital transformation of previous paper and manual processes fit like a glove for the maintainer at the edge. Initial estimates from the end user is an expected hour to an hour and a half of time saved per maintainer per shift. This makes a significant impact on operational capacity with a workforce that's already strained to capacity, if you will. These are the elements of the process flow we've digitized in airs. It's not, and I want to emphasize here, it's not just the process mapped and digitized, but it's delivered as an integrated system with existing maintenance and logistics systems and processes, but it's really automating that edge capability. The airman on the flight line, walking up and down, doing the work, managing the process. It's also important to note here that this digital transformation, whenever you do it at the edge, has to be able to flex, to be able to react to real world evolving operations. The last product I'm going to tell you about today in our digital transformation set of capabilities here on the Beacon platform is Connects. Connects is portfolio management. So it's really about how do you manage all the day-to-day activities of managing an S&T or an R&E investment to outcome. OSD, OUSW, R&E, Mantech is using this system to adjudicate their solicitations, to get projects underway, and to manage them. Where it's really fascinating in terms of the acquisition lifecycle, this fits with how do we take information from the edge and know what we should be manufacturing, how we should be manufacturing, if the way we built this actually worked the way we expected it to once deployed. So there's this whole initial intent of digital transformation and these multiple impacts that, if you're thoughtful to this acquisition lifecycle, can be brought to bear on other aspects of the spectrum: shared impact, data, and information. So a little bit more about Connects. They're using it to manage their support. One of the things that I really like about the implementation of, or about the digital transformation of S&T investments, is the ability to provide visibility to ongoing investments, the ability to flex and respond to emerging needs, not after they're done a report later that we go up and look at. It's a really great tool. They're having a great time working with it, and it's all about creating a better management of project risk and a better outcome. So with that, I think I'm done with my presentation. Anna, back to you. I'm happy to take any questions now if you'd like, or I could catch them later as well.
Great, thank you. Great presentation. I enjoyed seeing you talk about these products before, admittedly, but I'm always sort of thinking about how many diverse processes can be supported by these tools. Seeing you talk about flight line operations and portfolio management back to back. One question I have actually is, with that in mind, how differently do you approach building pipelines for data intake, for example, since I know Price talked about that and the types of data that you have to be able to acquire and build around when you're looking at tools that manage processes that I imagine can be radically different?
Yeah, I really appreciate that question. And in homage to our Boston Heritage, I will say that was a wicked awesome question, Anna. It's always fascinating to me how people use the same phrase and they mean so many different things across the board, right? So this is what I was trying to emphasize in what we do. It's really all about process. So I don't mean to disparage that the data structures are unimportant. They're wicked important. They're very, very important, right? And that's the IDE focus that Price was talking about, right? And there's different emphasis across the different spectrum of all these different digital transformation opportunities. It's fascinating to me in the conversations I've had in the past with Diesel about how their focus on and what they're doing has a really interesting intersection. I'll let him speak to it, but it's a slightly different focus, but a really lovely integration from what we're doing, and I think also to what Price talked about doing. So I think it's important that we understand digital transformation as one of those phrases that can mean a lot of things to a lot of people, but it's really important that we understand across the spectrum, it's just a different focus. Like, the IDE and the data is still important to us, but it's not what we're driving to. We plug into one that's really defined. I don't know, Anna, if that answers your question. I was trying to speak sort of a little more holistically. I hope I addressed what you were asking.
Yeah, absolutely. Thank you. It does. And we've got some other audience questions coming in as well, since we have a few more minutes left in your block. I'd love to get to those. A bit more concrete of a question here. Can you talk more about predictive maintenance and modeling that you can do?
So what's been really fascinating over the last couple of years is applied AI and the capabilities that we deliver. And what's more fascinating, and there are, like in the last webinar, there were some really spectacular AI specialists talking about what they do and how they do things. So I think the way I'd answer that question is what's intriguing to us is the ability to capture real world data, operational data that informs predictive maintenance models. It is really interesting to us to be able to embed applied AI into the operations at the edge so that you're not doing a fantastic science experience of an AI model, but you're doing this fantastic technology experience that then can manifest an impact of the warfighter. So around predictive maintenance, we have some of our own AI capabilities that we've built in. We've integrated other people's as well. I think for us, and again, this is that sort of spectrum perspective, our focus is on how do we fit like a glove for the end user so that we capture the data so that the models and the AI that we or others are using is informed by real world conditions. I don't know if that's, I hope that's what the person was asking.
Yeah, absolutely. And the chat feature remains open, the Q&A remains open. So if any follow-up questions come in, feel free to. I see Price is in the Q&A answering questions, which is awesome. Everyone should feel free to do the same. I've got one last question for you, maybe be related, but maybe you can speak broadly to this. What are some challenges you've encountered as you work with new government customers, and how quickly generally can they incorporate your tools?
Well, I'm happy to say that new government customers can more quickly adopt our tools because we've built the acquisition pathways for that to happen. Some of the work that I do at NDIA and the advocacy role is that was like a long and arduous process to set up, that we'd have contract vehicles, that we'd have program of record status, that we'd be compliant not only in an ATO or like a cybersecurity or an ATO, but have the right kind of security status and the ability to continually evolve our capabilities for them. Like with Connects, if someone wants to use that, it's hosted, it's at IL4, it'll be at IL5. We have a contract vehicle in which you can just engage and turn it on and start using it, but that took forever to build to. So the challenge that I'm happy that I wouldn't say we're challenge free, but over a hump on, that we should be really thoughtful to other digital capabilities coming into this space is not just how do we develop the capabilities and how do they work, but how do we acquire them? What do we need to do to make sure that we can rapidly get to what we can rapidly build now?
Absolutely. That makes sense. I think that speaks to a lot of the themes we're trying to cover throughout the whole of this series, not just this webinar. So appreciate that. With that, thank you so much, ML. Wonderful presentation. Thank you for taking questions. We're going to move along to our next presenter, which is Robert Diesel-Salvia. He's the Vice President of Federal Operations at Fortress. Fortress Government Solutions provides critical supply chain cybersecurity solutions that protect defense critical infrastructure and weapon system supply chains from cyber threats. FGS solutions include third-party risk management, software and hardware supply chain security, and vulnerability management. Fortress focuses on DoD, government, and energy sectors, enabling regulatory compliance and enhancing overall cybersecurity resilience. With that, Diesel, I will hand it off to you.
Thank you. Let me get the slides up. If everyone can see those. Okay. Again, thank you very much, Robert Salvia, Vice President of Federal Operations for Fortress Information Security. I'm really happy today to join this group and talk about how cyber supply chain risk management solutions fit into digital transformation in acquisition today. A little bit about what we're talking about is just who Fortress is, how long, where we came from. Digital transformation, I know this is the third webinar, so there's just a recap of what that brings to acquisition, as well as what cyber supply chain risk management brings to digital acquisition and why it's so critical to ensuring that security over the life cycle of any systems that are fielded. Fortress has been around since 2015, providing enterprise-level cyber supply chain risk management solutions. We started with critical infrastructure and have since taken the best practices and lessons learned of how to do that at an enterprise level and moved it into the Department of War. We provide comprehensive solutions, and for complete and successful cyber scrim solutions, we combined traditional scrim, compliance, and cyber regulations into a comprehensive cyber scrim solution that breaks down those walls. We also have collaborative, where we work closely with our customers to give them customized solutions mapped to the regulations that they need. And really the biggest focus here is conclusive. Giving tens of thousands or hundreds of thousands of vulnerabilities just in a list does not help anybody. It just creates noise and slows down the acquisition solution. It's really branching that and mapping that across an enterprise and rolling up all of those into a prioritized list where you get the highest return on investment for what needs to be fixed, where it needs to be fixed, and how to fix it. We currently 40% of the US power grid is being secured by Fortress and Fortress tool sets, and 4 military branches and defense agencies, to include the Navy, the Army, the Air Force, and Department of Homeland Security, are using our solutions as well. So again, digital transformation and acquisition, it's really to rapidly procure, integrate, and deploy advanced technologies. And traditional acquisition and procurement tool sets are too slow to keep up with the advanced technologies that are coming through and aren't adaptive enough to maintain that security throughout. But as you speed up acquisition, you bring in some additional layers of compliance and risk mitigation that have to be addressed, and they can't be addressed after the fact. Add to that digitalization and globalization of the supply chain, you're going to start to introduce new threats that weren't there in the past, including cyber attacks, data breaches, mergers and acquisitions of your vendors, vulnerabilities in third-party software as well as hardware. And we're talking about life cycle systems that last now for upwards of 30 years on some of our systems as they go through engineering change proposals, tech refreshes, upgrades. All of that has to be managed. So managing those cyber risks, it really has never been at a higher priority right now. And oftentimes when we introduce new things that want to bring speed to the fleet, we start to rely less on security because we're so focused on speed. And what really needs to happen here is you need to balance the need for speed to the fleet, but make sure that you're building in robust security right from the start so that you don't have losses on the back end of the acquisition. What our solution does and how it supports digital acquisition and transformation is accelerating the acquisition timeline up front, as well as ensuring security throughout the entire acquisition lifecycle through operation and maintenance. How do we accelerate it up front is through AI tools, and ML is streamlining the vendor and product onboarding. We reduce that manual effort. We accelerate the timelines to get products secured and get the actual systems through milestones with cybersecurity certifications. Standardizing risk assessments. This is what breaks down the stovepipes where people are using different tools, different methodologies, different third parties, only identifying their own risk. Couldn't compare that risk. You couldn't share that risk. And everybody had to go on their own timeline to get things. That was not conducive to rapidly acquiring advanced technology. So by having those standardized risk assessments, it increases data-driven decision-making and accelerates that process. Also, by integrating cyber scrim into the digital workflows and MBSE models that Bryce was talking about earlier, doing that up front is going to buy you a lot of time as you go through milestone certifications, as well as reduce your downtime and cost to replace. Ensuring that security throughout the life cycle, that's really where we are born to be that enterprise level solution to maintain cyber resiliency where you need to go stay and fight. Identifying the vulnerabilities early is great so you can deliver cyber ready systems upfront upon delivery. But it's not a one-time compliance check. It's not a snapshot. You have to continuously monitor these over the life cycle, 20, 30 years through all of the engineering change proposals, refreshes, upgrades, and new cyber threats that are coming online. That has to be managed so that you can be ready to fight. That's done through continuous monitoring and compliance. Rather than running entirely new packages, you have situational awareness of your risk, you have continuous compliance, and you can respond quickly to what those new threats are through incident response integration. mapping out all of your systems, your hardware, your software, knowing where they are, not just in a single program, but across the entire enterprise. So whether it's assessments that we find that have been mapped out or external ones, you can quickly respond to those cyber incidents and get those systems back online. And the platform is fully accountable and auditable. So whether you're going for a certification or need to prove some incident response backlogs, all of that can be pulled directly from the platform. One of the main things that we talk about too is where we talk about collaborative. So comprehensive, we bring in multiple external data sets as well as internal organic data sets and roll up not just vendors, but vendors and the products that they produce, hardware and software. And we prioritize all of that into a cyber heads-up display where people can actually action the findings that we bring to them. This heads-up display is multi-tiered in that it can do executive level reporting across the enterprise, but all the way drill down into the programmatics where there are executable and managed findings that they can then remediate and report up the chain. Here's a quick demonstration of one of our live dashboards.
Dashboard, I would configure that and be able to highlight the specific risks, insights, whether the focus is supplier exposure, critical software, hardware dependencies, or foreign influence, we align the scoring and visualizations to your mission priorities and define risk tolerance. All of the data you see here is driven by continuous monitoring by Fortress. We collect, normalize, and assess supplier, software, and hardware risk on an ongoing basis, providing validated, decision-ready intelligence. In addition, we can integrate with your existing tools, including vulnerability scanners, asset inventories, threat intelligence feeds, and any other sources you might have to ensure this dashboard reflects your full risk ecosystem. At the executive level, leadership can immediately see overall risk posture, including total number of vendors, total number of products, critical suppliers, and open risk mitigations. Risk is not presented as raw data. It is prioritized using impact and likelihood modeling aligned to the defined thresholds. The vendor risk matrix quickly shows where the most critical exposures exist. From there, users can drill into the top riskiest vendors, software, or hardware to understand exactly what is driving the risk. Supply chain transparency is mission critical, and this dashboard also visualizes foreign presence and geographic exposure across both vendors and products, supporting compliance with federal mandates and executive requirements. The result is actionable supply chain risk intelligence aligned to your mission.
So the dashboard is fed by all the products that we deliver on both vendors, hardware, and software, and that's what's rolled up and actioned. For vendors, we go beyond traditional scrim of who is this vendor, can they supply what you need, where you need it, in the quantities that you need it, which is what traditional scrim is looking for. And we start to look at it to include cyber scrim that says, should they be the ones providing that critical technology, or is there an instance where they shall not be? So understanding that is critical to illuminating your vendors. We've also, all of our reports have been mapped to the DoD scrim taxonomy, 12 risk categories, and rolled up into 5 that are actionable. You can customize this at any level. And all of this is continuously monitored because over a 20-year life cycle, you can see vendors that go through mergers, acquisitions, have critical breaches. You need to understand the structure because that is where the risk is going to occur at that lower level. Here's some more detail on one of our vendor reports.
Fortress actively monitors suppliers, and when we identify a relevant risk event, it is brought directly into the platform as a structured finding. These findings are categorized, scored, and prioritized to reduce noise. If we click on the vendor list up here, we can see all of the vendors that we have enrolled in our monitoring, and we'll see that they have scores in operational risk, financial risk, regulatory risk, cybersecurity risk, and foreign ownership control and influence risk. And all of these findings are mapped to the Office of the Secretary of Defense's taxonomy for supply chain risk. They have 12 areas of risk, and we map to all 12 of those. And we broke it down further into these 5 categories on the screen, just so it was easier to digest and operationalize for the customers. I'll go ahead and click into one of these reports so you can see exactly what it entails. When we drill directly into an individual supplier, we can understand what is driving their risk profile. So we have those categories of risk as determined by the Office of Secretary of Defense here. And we'll see that, for example, if there are cybersecurity incidents, exposed credentials, vulnerabilities, or regulatory events, that might be driving the score of this specific vendor. And if we scroll down, you'll see that we have transparent scoring, so you know exactly why a vendor was scored a certain way. And here you can see how we break down those 12 Office of Secretary of Defense categories of risk into 5. We also bring all of these findings into the platform. So here we can see, as we're monitoring this specific vendor, we have 55 different alerts, and these all get brought into the platform so we can create different workflows. If we wanted to go ahead and create a plan of action and milestone to either remediate this, mitigate it, do some sort of risk acceptance approval, or whatever that workflow may look like for you, we could go ahead and kick that off.
In addition to the comprehensive approach, again, not just vendors, we look at the products that they produce, the hardware and software within those products, where it sits in the architecture, and how critical it is to mission execution. Software supply chain is one of the highest targeted areas in supply chain risk management, and often the vulnerabilities that we find are down at the subcomponent level of the SBOMs. So we have multiple ways of exposing and getting that down, some being open source, binary analysis, reverse engineering, and we look for a multitude of different vulnerabilities across the entire software components and subcomponents. And all of this is critical specifically with software to be continuously monitored so that different version control and configuration management can exist throughout the entire life cycle of that system as it's upgraded, refreshed, and goes through changes. Here's some more about how we illuminate the SBOMs.
Fortress ingests and analyzes software bill of materials and reports out data that you can operationalize, as well as risks that you can action. In our example here, you'll see that we can look at the metadata to see what the software is, the operating system, and if we scroll down, we can see all of our different risk areas. So what we're doing here is tearing the software apart and identifying each specific component. And on that component, we're determining if there are any vulnerabilities. And if there are vulnerabilities, what the severity of those vulnerabilities are. We're also looking at dependency risk to see if these components are any major or minor versions behind, looking to see if there's any malware, and then checking for foreign presence. So this would be checking to see if there's any code contributions from any adversarial or high-risk countries, any corporate relations, contributors, and other foreign presence that you would be interested in seeing on this specific piece of software. Now, we can also see the dependency relationships. So this shows us exactly how these components are dependent upon each other and where those vulnerabilities lie. So if they're sitting all the way at the top, closest to the root component, or further down on the dependency tree. And all of this data gets brought into our Fortress platform here. So you can see we have all of our vulnerabilities, all of our components, and then all of these vulnerabilities will roll up into our dashboard. So you can quickly see exactly what the most critical vulnerabilities are on your most critical products. And these will roll up into your systems, in your platforms. So no matter what view you're looking at, if it's all the way down at the component level or all the way up at a system or platform level, you'll get insight into what those vulnerabilities are and where they lie.
And bringing all those into the platform is critical to map across the enterprise. As we go down to the subcomponent level and we have lots of common systems and common software, you can see that those vulnerabilities lie across, not in a single program where it used to be stovepipe, but you can see how wide the breadth of those vulnerabilities are across the entire enterprise. We also do this for hardware as well, sometimes with vendors and software being the tip that everybody looks at for supply chain risk management and cyber. Hardware often gets overlooked, but the hardware subcomponents really are, they have a lot of vulnerabilities in themselves, and each one of those subcomponents do not often get illuminated within the bill of materials or parts list. They are just rolled up into the system in which they are. So there's completely no visibility that you have certain vendors or certain vulnerabilities at the subcomponent level, to include counterfeit, non-conformance, banned entities. All of that needs to be exposed, illuminated, and again, specifically with COTS and common systems across the enterprise, you may have a situation where a certain piece of equipment has a vulnerability that is not even visible to the programs that have bought them and has been propagated over 1,000 times across the entire enterprise. And that's what we do by pulling this in, illuminating it, tagging it, and mapping it across the enterprise. Here's a little bit more of what we do there.
When viewing a specific asset, we can see all the different pieces of data we've collected and all the different risks that have been identified with this specific asset. In this case, we're looking at the Siemens RuggedCom RMC30, and here you can see that we've identified 14 assessment findings. We have 171 components. These are all the pieces that make up the actual asset. And we identify those between software and hardware, as well as the different type of components. So you might have oscillators versus capacitors, for example. We bring in all of our vulnerabilities, as well as any fourth-party vendors. So in this case, it's not just Siemens that's manufacturing this RuggedCom RMC30, but there's actually 29 different suppliers that have been identified through our assessments. And that's part of our verified approach to identifying those fourth-party suppliers. And we get these different risks and insights and data points from a few different assessments. One I'll walk through here is called our Product Assessment Provenance Report. This is a product teardown where we actually bring the asset into our headquarters at Orlando in our lab and do a complete teardown to identify every single component. And we document the whole process. So here you can see this is what the device looks like. And as we scroll down, you'll see that we take it apart to the component level and document each one of those components. And as we're doing this, we're looking for hardware vulnerabilities, software vulnerabilities. We're looking for any alerts, such as obsolete components, any components that have been tampered with, banned entities, components that come from banned entities, as well as their country of origin. So you'll see as we go through each component, we determine who that manufacturer is. This is where those verified third parties come from, what those manufacturing partners are, and country of origin. And as I showed before, these findings all get brought into the platform. So this allows us to operationalize these risks and do remediation or mitigation. And there's also continuous monitoring done throughout the life cycle of this asset.
And then when we talk about being conclusive, and it's not what you find, it's what you fix, we have the ability to automate incident response and campaigns. And sometimes those campaigns can be kicked off by the assessments that we do, providing vulnerabilities down to the subcomponent level on software or hardware or vendors. And as you saw in the demo, you can start a POA&M directly with those programs that are affected, and you can track and manage all the way from initial finding to closure on all of those vulnerabilities. But also sometimes they're more structured, such as XORs or fragords that get sent down to the enterprise level, and then it shortens the time to go find out who has the vulnerability, how is it impacting them, and what are they doing to solve it. All of that can be automated within the platform itself. And again, the platform is accountable and auditable, so you can go back and trace when were they notified, what actions have they taken, how far along are they in the progress, and when will it be complete. So to wrap up, how does Fortress Enterprise Cyber Scrim Solutions support digital acquisition? It really is about taking those best practices that have been learned over a decade and bringing the comprehensive, collaborative, and conclusive, continuous monitored solutions to the Department of War, all the way down from the program level to the enterprise level. When we talk about being comprehensive, it's not just breaking down the walls between traditional Scrim compliance and cyber, but it's also closing the gaps between different programs that have siloed their answers and bringing that across the enterprise so you can see all of the information at different views so you know where your risk lies, where it is, why it matters, and how to fix it. The collaborative piece is, again, breaking down those silos, working with the customers and the regulations that they're following, the different systems that they have, helping them define the risk thresholds that are going to set triggers that are either going to be accepted or beyond that trigger that they're going to have to remediate. And then conclusive. Continuous monitoring and incident response across a 20-year life cycle as they go through engineering change proposals, tech refreshes, and upgrades is critical to maintaining that technological edge for the warfighter as they go out and fight. Fortress, we currently have ATOs in the IL5 and IL6 environment where we can operationalize this data directly to mission readiness. We have multiple contracting vehicles through DxA and sole source IDIQs. And again, Robert Salvia, really happy to have this conversation. I'm a bit passionate about it, so 20 minutes is tight for me to get it all in. I've been doing this now since I was in uniform and since I moved on. So thank you all. We're ready for any questions.
Awesome. Thank you so much. I was really interested to hear about the different approaches you take to secure software versus hardware and how you break down to the component level to find vulnerabilities. There's a related question I would love to highlight, which is, could you help identify cases of diminishing sources for hardware or even software that is not supported anymore?
Absolutely. And that's one of the things that we do when we go across hardware and software. Some of those vulnerabilities that we look for include obsolescence, last time buys, even recommended for not recommended for long-term buys where they say it's going to be phased out. We look at software end of life versions, and also through our external data sets, we can look where you think you may have redundancy on certain products because you're buying from 10 different suppliers of say a certain product. But if you go 1 or 2 layers deep, you can see all 10 of those vendors are all requiring to buy one specific piece from one vendor. So we're identifying those sole source areas that, again, are blind to the programmatics, but could present a problem deeper within the supply chain.
Awesome. Thank you. In the interest of keeping us on time relatively, I'm going to move along, but there are a few other questions that have come in for you in the chat if you're willing to go take a look at those.
Absolutely. I'll jump in. Thank you.
Awesome. Thank you so much. All right, so for our final presentation, we'll hear from Timothy Stamper Gramp, who we appreciate very much being here with us today since he had an early morning on the West Coast, 3 hours ahead of where I am at least. He's the Chief Technology Officer for Expantia. Expantia accelerates digital transformation and acquisition by designing, integrating, and sustaining the digital backbone of mission-critical defense platforms. The company combines commercial-grade technologies, engineering rigor, and purpose-built digital accelerators to improve technical data visibility, compress decision cycles, and drive measurable mission impact. With that, Stamper, over to you.
All right, find that mute button. Well, thank you, Anna, for that introduction and for an opportunity to be with you all today. It's going to be an interesting journey as you started with architecture, you dove into process, then got some view of some tools and some process. And now I'm going to bring us back to architecture, I think at a slightly different level than Price talked about in the beginning. So I hope that this is an enjoyable discussion for you. So as I said, I'm not going to talk specifically about tools or definitions or tool implementations today. Rather, I want to talk about what becomes possible when we architect digital acquisition intentionally. Because when it's engineered correctly, the digital thread stops being documentation and it becomes decision advantage. So I'm going to start with a simple and hopefully not controversial assertion. Digital acquisition isn't a collection of tools. It's not a dashboard. It's not a model repository. It's not a cloud migration. It's an engineered ecosystem. And the purpose of that ecosystem is to compress the time it takes to learn, integrate, and decide. Now, often when we talk about speed, especially in acquisition, we're focused on schedule. But that's not the speed I'd like to talk about today. Rather, speed in this context is about reducing cycle time in learning and decision making. Now, if we can agree on that, the architecture starts to look different. Okay, first, let's unpack my concept of speed, and hopefully quickly. If speed is the goal, the first question we should ask is, speed of what? I'd argue that in acquisition, there's really 3 types of speed that matter. The first is learning speed. How quickly can we move from a question to a validated insight? If an engineer wants to understand a design trade or test an assumption or evaluate a risk, how long does it take to get credible evidence? If that process still requires reconciling spreadsheets and manually tracing requirements to drawings, we're not learning quickly, we're administrating data. The second kind of speed is integration speed. How quickly can we insert new technology, bring in a new supplier, adjust to a changing mission need? If every integration requires bespoke engineering and manual coordination across stovepipes, then the architecture is fragile, and fragile systems don't integrate quickly. The third kind of speed is decision speed. How quickly can leaders move from data to action? not just with information, but with confidence. If program reviews spend half their time debating which data set is authoritative, then we don't have decision speed, we have data friction. So when I talk about speed in digital acquisition, I'm talking about compressing learning cycles, integration cycles, and decision cycles. And that kind of speed doesn't come from enthusiasm, it comes from structure. I'd say it's engineered. At Expantia, when we think about the digital ecosystem architecturally, I'd like to break it down into 3 conceptual layers. At the bottom is the trusted foundation. In the middle, the digital integration core. And at the top are the modular mission applications. I'm going to go ahead and dig into each of these layers a little. First, the trusted foundation includes cybersecurity, which we just heard quite a bit about, identity management, compliance boundaries, cloud and on-prem infrastructure, network, and compute. It answers a very basic question. Can we trust the environment in which our digital processes operate? If identity is weak, federation breaks. If compliance boundaries are unclear, integration stalls. And if infrastructure is brittle, automation fails under stress. This layer isn't glamorous, it doesn't show up in dashboards, and it probably doesn't make it into too many briefs. But without it, everything above it becomes unstable. Designed well, it makes the ecosystem survivable. Now at the top are the tools people see. This is the place where many digital transformation efforts go to die. System modeling tools, product lifecycle management systems, computer-aided design, workflow platforms, dashboards, analytics. It's easy to invest in a piece of software, but without careful integration, you can end up with more friction than speed. And don't get me wrong, these tools are important, but they aren't the ecosystem itself. They're consumers of it. If the underlying integration core is strong, these tools are modular. We can swap components, we can compete, we can evolve capability without destabilizing the enterprise. But if the core is weak, those tools become silos. And so that brings us to the center of gravity, the digital integration core. Excuse me. The integration core is the heart of our ecosystem. It's where digital truth is established, where change is orchestrated, and where evolution is automated. It answers 2 fundamental questions. What's true, and how does change propagate safely? I propose there's 3 essential capabilities inside that core. First is authority. Authority means that the requirements, system models, configuration baselines, test results, and sustainment data are aligned and traceable. If the requirement in the contract doesn't match the requirement in the model, we don't have authority. If the configuration in the field doesn't match what's in the PLM, we don't have authority. And if sustainment data never feeds back into design decisions, we don't have authority. In that case, we're not acquiring digitally, we're digitizing artifacts. Authority is what anchors trust. Second is orchestration. And this is another place where many transformation efforts struggle. Orchestration isn't about duplicating data across tools, it's about federating it, linking it semantically, exposing it through secure APIs, and propagating change through event-driven mechanisms. When something changes in one domain, that change has to be visible and traceable across the ecosystem. If the requirements shift, design knows. When design evolves, test knows. And critically for many of our clients, when sustainment sees a pattern, engineering has to know. When data is federated rather than duplicated, and interfaces are cleanly defined, something else happens. Architectural freedom of action increases. Now tools become options rather than anchors. Finally, the third capability inside the integration core is evolution. Now stay with me because I'm still talking about this at the architectural level. So no CI/CD pipeline talk just yet. An ecosystem that can't evolve safely will eventually fracture. We all know requirements change, especially in a cyber world. Threats evolve and they're faster and faster every day. Technology advances at a pace that even a chief technologist can barely keep up with. If the architecture doesn't contain a built-in mechanism for controlled change, then change happens informally. And informally managed change is where configuration drift begins. This layer ensures that change is not ad hoc. It provides a governed path from concept to validated baseline. It allows infrastructure definitions, models, automation services, and software components to move through controlled states, development, integration, test, and production, without breaking traceability. Without this layer, the digital thread exists only at milestone reviews and CEDAR events. With it, the digital thread becomes continuous. At this level of abstraction, I think the key point is simple. The ecosystem must contain its own evolution engine. Otherwise, speed collapses the moment the first change occurs. Now, all this architectural discipline, authority, federation, controlled evolution, it produces something larger. It produces architectural freedom of action. And that's where MOSA, which we heard a little bit about earlier as well, or Modular Open Systems Approach, enters the conversation. Because MOSA at its core is about preserving flexibility in the face of change. It's about enabling competition without destabilizing the system. It's about inserting capability without redesigning the enterprise. But MOSA can't be declared at the tool layer. It has to be enforced in the integration core. Modular interfaces require clean data boundaries. Data decoupling requires federation, not duplication. And competition requires accessible, authoritative information. When the ecosystem is engineered correctly, MOSA stops being a compliance exercise and it becomes an operational advantage. All right, so that's the abstract view of our approach to the digital acquisition ecosystem: a trusted foundation, modular mission applications, and a governed integration core that delivers data authority, orchestration, and continuous evolution. I'd suggest that speed emerges from how well that core is engineered. Okay, I made it this far in the discussion and I haven't yet said artificial intelligence. I probably have to forfeit my CTO card. Time to address our rapidly evolving view of AI in the digital acquisition ecosystem. If you're watching the stock market or reading LinkedIn, you couldn't be blamed for thinking that AI has rendered nearly every human information process obsolete. And I certainly know there's a lot of excitement about AI and acquisition. Much of it is justified, no doubt, and some of it is premature. If we're going to introduce AI, and here I'm specifically talking about generative AI, into acquisition, it can't operate as a chat assistant on the side. It has to operate as a governed participant in the engineering workflow. But governed how? I like to think of it as digital rules of engagement for AI. AI must operate within defined context boundaries. It needs to have explicit tool permissions, and its actions have to be logged and traceable. At the end of the day, its outputs must be transparent. AI can perform the acquisition functions, but humans need to exercise judgment at the appropriate level. This isn't about replacing engineers. It's about accelerating them. We've already begun adapting our digital acquisition ecosystem architecture to allow LLMs and generative AI to engage alongside human engineers. These AI agents can continuously cross-check requirements against system models and update those models when requirements inevitably change. Other agents review interface compliance. They detect changes in ICDs and recommend updates in our platforms. Real-time monitors identify inconsistencies in configuration and generate recommended corrective actions. We use agents to generate draft test cases that again remain synchronized with system models and requirements. Across the acquisition lifecycle, AI can be used to spot risk patterns and ensure our designs and sustainment plans remain aligned. But of course, there's a few catches. In order to achieve these benefits, AI must be able to safely access authoritative models. It has to be able to operate across diverse tools and function consistently when those tools are changed. And so, we treat AI as a system component governed like any other component. And if you're not yet familiar, the emergence of Model Context Protocol, or MCP, in the past year is proving both an excellent mechanism of governance and a change management layer as LLMs continue their breathtaking evolution. So that's how we're taking AI from marketing hype to an engineered capability within the ecosystem. And when engineered properly, we're seeing AI compress those learning cycles dramatically. Now, let's talk about one more component of our approach to the digital acquisition ecosystem. And it's an area that often gets overlooked. A real differentiator in our DAE is not just building the prototype, it's retaining the factory that evolves it. In our experience, particularly on programs where we're operating in sustainment modernization environments, the moment the prototype works, the temptation is to disband that disciplined delivery structure and shift into maintenance mode. That's where decay begins. Because without a retained software factory, the ecosystem starts drifting almost immediately. Not catastrophically, but quietly. Models drift because changes are made locally but not reconciled globally. Environments diverge because development, tests, production configurations evolve independently. And security baselines erode because patches are applied reactively rather than structurally. We've seen this firsthand. On one effort, we were just building a digitally integrated environment to support part analysis and advanced manufacturing. Early progress was strong, but the real lesson came after initial deployment. The question wasn't, can we build it? The question became, can we evolve it without breaking it? And that's where the factory matters. A digital acquisition software factory doesn't just run CI/CD pipelines that produce new software applications. The factory governs infrastructure as code so environments remain reproducible. Model repositories can use the factory so authority remains intact. The software factory manages middleware and integration services so federation doesn't decay. And of course, it enables cyber compliance automation so ATO posture doesn't regress every time a dependency updates. It becomes the lifecycle backbone of the ecosystem. By retaining the factory after initial deployment, tech insertion accelerates because the pipeline is already built. As I mentioned earlier, MOSA compliance can be continuously validated rather than asserted as milestone reviews. Security patching becomes routine rather than disruptive, and competition can occur without destabilizing the baseline because interfaces and infrastructure are version controlled and test validated. And here's perhaps the deeper point. The factory doesn't just deliver speed once at initial ecosystem deployment, it sustains speed. Without it, the digital thread becomes a milestone artifact. With it, the thread is operational. And that distinction is critical in long-lived platforms, especially where configuration integrity, cross-tool traceability, and cyber posture can't afford entropy. Speed in this sense is a managed, repeatable condition of the system. All right, I'm going to try to make this a little more concrete. We've worked with a number of our nation's well-established air platforms, ones that have undergone decades of modernization. Think avionics inserts, communications upgrades, weapon integrations, cyber overlays. Now, imagine a hard-to-source component driving readiness risk for one of these platforms. Perhaps the original manufacturer no longer is in business. Perhaps we never bought the technical data. In a traditional acquisition environment, reconciling that issue requires manually tracing sustainment data back to engineering drawings, then validating configuration baselines, then confirming certification impacts. Trying to manage this in spreadsheets can quickly exceed human capacity. On platforms of this age and complexity, that process can take months, if not years. In the architected ecosystem, it looks different. Sustainment data surfaces the readiness trend early. A governed AI agent queries authoritative requirements in configuration data. The tail-specific configuration is cross-referenced against the system models, and relevant digital artifacts can be retrieved from the PLM. Simulation validates a revised manufacturing or replacement approach. The software factory pipeline promotes the update into test, and automated cyber validation confirms baseline compliance. The result? An updated technical data package is fielded, and an alternate part sourcing becomes possible. The non-mission capable platform can be returned to operations. The difference isn't automation for its own sake. The difference in that is that the ecosystem has been engineered to compress the time between signal and action. On long-lived aircraft programs, that compression directly affects readiness. So let me close this way. Over the past few years, we've all watched digital acquisition evolve from an idea to a mandate to something programs are actively trying to implement. But the real question isn't whether we have models, or whether we've migrated to the cloud, or whether we stood up a dashboard. The real question is this: did we engineer the environment in which decisions are made? Because that's ultimately what matters. At Expantia, we've had the privilege of working alongside programs that are trying to modernize real, complex, long-lived systems. And what we've learned is simple. When the ecosystem is architected intentionally, when authority is clear, when integration is disciplined, and when evolution is governed, something shifts. Engineers stop reconciling artifacts and start solving problems. Leaders stop debating data and start making decisions. Programs stop reacting to change and start absorbing it. And that's when learning cycles compress. That's when integration becomes resilient. And that's when decisions become faster and more confident. And in the end, that's when readiness improves. Speed stops being a slogan. Our belief, and the reason we invest so heavily in the digital acquisition ecosystem approach, is that architecture is the lever. If we engineer the ecosystem correctly, the outcomes follow. Better decisions become inevitable. And I think if there's a minute or two, maybe one or two questions, now's an opportunity to ask.
Great, thank you so much. Great presentation. I really liked a point you made early on, actually, and one that I think that's been echoed through a few of the presentations today about treating tools themselves as components that should be modular and swappable within an architecture. As you said, I'd love to sneak in a question really quickly. I know we've had a few come in from the audience. So you were talking earlier about the importance of access to authoritative data models. So someone asked, should we think of Advana as the authoritative data source for acquisition programs and officials? How do you identify relevant authoritative data sources? And I would actually add on myself, is that part of your building or integration process, or is that even done on the part of the programs instead?
Great question. And wow, such a timely question, because we've been wrestling through Advana and the service variants, Jupiter in the Navy, Blade in the Air Force. And the questions about what data is available in those environments and how accessible really are those data sources. So we definitely are thinking through that. I would not limit it to Advana. There's certainly, I think, just the timeline has brought a lot of financial data into Advana early on. Logistics and sustainment data has followed, so that's been a great source of data for us, but it's not yet exhaustive. It doesn't yet have all the data. And what I'd offer, beyond just the kind of either sustainment, logistics, or technical data that might end up in the Advana, Blade, Jupiter sort of ecosystem we know today, we're talking about real-time system data as well. Often that data needs to come back from operational platforms themselves, and that data doesn't necessarily make it into a system like Advana. So getting the feedback at the right level and with the right latency to inform kind of the evolution of the platform or the evolution of the ecosystem is something that we spend a lot of time thinking through. So I guess in short, Advana, Blade, Jupiter, that ecosystem, very important, and having that connection to an aggregated source of data, very important. I don't know that it'll be possible to truly centralize all that data. Again, as you think also about operational data and how that informs the overall system architecture. So that's a piece that we're constantly sort of evolving through.
Perfect. Thank you so much. I want to thank all our speakers for showing us some really interesting case studies today, and to the audience for their questions, which were wonderful as well. I think we've seen a very strong overview of how the industry is supporting the department's digital transformation efforts for many different pieces of the acquisition lifecycle. And to close out today's webinar, I'll hand it off now to ETI's Executive Director, Dr. Arun Serafin.
Thanks, Anna. I want to thank all our speakers today for these really cool presentations and demos. Thanks especially to Anna for doing such a great job moderating the session. I guess I took away that these technologies and services are real, and they can be adopted today by other programs and activities with very limited modification, and they can start producing tangible results. And the other thing that was nice is they seem to hit across the whole life cycle, from planning for programs to development stages of programs to even maintenance of systems at sea. In fact, the hard work that these companies have done to pave the ground is going to make it easier for other government organizations and programs to be able to access these kinds of digital services. No new laws required. That this is legal. People are doing it already. However, there is clearly a need for data collection and sharing to feed these capabilities in the best possible way to let them optimally support improving acquisition outcomes and decision speed and decision-making quality, and of course, to get to improving system performance to the extent that these guys are already demonstrating. So, I mean, for me, I think I'd love to work with everyone here to help highlight those government programs that are really leaning forward and doing the right thing here in using digital acquisition capabilities as a way to help all of our companies share what they're doing well and spread best practices. And Stephanie, hopefully we can keep working in this area. So again, thanks to Anna, thanks to all the panelists, and thanks to Stephanie for putting this together. With that, I want to take a moment to highlight a few of our upcoming events at ETI. We have the final installment of this webinar series on March 18th from 1 to 2 p.m. We're really proud and pleased to feature a fireside chat with Dr. Will Roper, CEO of Vistari, and he was the former service acquisition executive for the Air Force. And that's going to be moderated by Beth Stopkeen, who's at Keen Edge Strategies, and she's formerly a senior advisor in the Office of the Undersecretary for Research and Engineering and a PSM on the House Armed Services Committee. Our next Tech 101 webinar will be on March 19th, and that will be an introduction to defense radar for non-specialists. And then on March 26th from 1 to 4 p.m., we're actually going to hold a hybrid rollout event. The in-person part will be right here in Arlington at NDIA's offices for an ETI report that we're rolling out on how to mobilize private capital for defense. To register for these and other ETI events, please visit ndia.org/events. If you have feedback about this event or any other events that ETI is running, please email us at eti@ndia.org. Thanks once again to the panelists, and thanks everyone for joining us today.